Welcome to Network Automation Heroes. We're going to be talking to Bryan Ward from Dartmouth College today, and we're going to be talking all about how NetBox, and in this case, specifically NetBox Cloud, can be used to manage Juniper Mist. Hey, Bryan, how's it going?
I'm all right. How you doing, Mark?
I'm doing really good. Yeah, I was going to, it's great to see you. I was going to ask you to tell our viewers and listeners a little bit about yourself, because you and I have been speaking pretty regularly since kind of 2022, I want to say, about various NetBox things, but maybe there are people out there who don't know who you are yet.
Sure. So I'm Bryan Ward. I'm the lead network engineer at Dartmouth College. It's the smallest, but not the least important, Ivy League school up in Hanover, New Hampshire. So about 2 hours north of Boston, for those of you who aren't familiar with the geography. I've been here about 7 years, I think. And we've been using NetBox since some version of 2.0, when it was just an open source thing. And it's been about 5 to 6 years of that since we first started looking at NetBox, and it's been a great tool for us. So happy to take the time today and speak a little bit more about that.
NetBox has changed a lot. We're going to speak in a minute about how Juniper Mist has changed a lot as well. Just before, maybe just to add a little bit more color to Bryan's background, just before we started recording, we were chatting about how we've overlapped a little bit in our previous careers, although Bryan at a much larger scale than me. I used to help out on some little music tours, helping sound guys do stuff in little bars. But Bryan, you've done this at about as big as it gets kind of scale.
Yeah, but before working at Dartmouth, I worked in the rock and roll business. I worked as almost like a roadie, touring with shows, going out, doing special effects, mechanical automation. So now I'm doing network automation, IT, Wi-Fi. And I worked just before Dartmouth. I worked at the Radio City Music Hall in New York City, and introduced them to the joys of Ethernet and IP-based networking. So,
wow. Okay. Yeah. I think if I was to say all of the venues I ever helped at, no one would recognize any of them or the artists I was with. So you definitely win that one, Bryan.
Yeah. Well, you got to start somewhere.
You got to start somewhere. Yeah. But I flipped straight back to IT. I was like, the money's not good enough here in music. So just a quick agenda for everybody who's watching. These things can sometimes be up to an hour. It really depends. I just want to give you a view of kind of what's coming up. When we do put this up on YouTube, you'll see that it's all sections. So if there's a specific part you're really interested in, you can jump to that. But we just did welcomes and introductions. I'm going to kick off by just giving a general sense of the state of the union for network automation, just to help everyone kind of place themselves in where this might be applicable and where Dartmouth is on that sort of maturity scale. After that, we're going to talk about Juniper Mist more. If you're watching this, you're probably familiar with NetBox because you probably heard about it through us. But some of you may not be familiar with Juniper Mist. Juniper Mist is super popular, and Bryan's been working with it for a ton of time. And actually, maybe let's get into that now. I believe you started at 2.0 for NetBox. So you're an early adopter of NetBox. And also, I don't know what version it was, but you got in pretty early with Mist too.
Yeah, so I think the Mist APs that we got off the truck had version 0.1 pre-installed. So yeah, we've been a very happy Mist customer since before Juniper was even part of that picture, back in 2019. And we've been using NetBox right along with Mist and with Juniper for route switch the entire time. We've been developing our automation workflows together.
Well, you're known for this both at NetBox and at Juniper now, because just the other week we were speaking to some of the guys from the Mist product team over at Juniper, and they said, you should just speak to Bryan Ward. He knows more about it than we do. So you've definitely been in the trenches.
Yes. Digging the trenches.
Digging the trenches and then getting in them. Okay, very good. Just keep going with the agenda. We're going to look at, there's a lot that Dartmouth are doing with NetBox and Mist, and we're going to separate it a little bit. First, we're going to look at like the general flow based on the NetBox Labs reference architecture, so you can get a high-level view of where the different touch points are between NetBox and Mist. And we're going to look at some cool stuff that Bryan's brought as well. Bryan's brought a deck where he's going to be showing us some of the specifics, and then we're going to focus in on this one use case around doing firmware upgrades driven by NetBox into Mist. And after that, I'm sure there'll be a ton of things we want to discuss, so we'll get to those too.
Yeah.
You all right to jump in, Bryan?
Let's do it.
All right. So let's talk about the state of the union for network automation. That's a bit of a lofty name for this, actually. But like I said earlier, I just want people to be able to orient themselves. We speak to just hundreds and hundreds and hundreds of businesses that are, interested in NetBox or in our community somehow. And by doing that, we came up with this like pretty high level way to think about where they are in their network automation journey. Um, you know, you can see down here, bottom left, 72% of organizations are still within these first two phases. This data comes from Enterprise Management Associates. So some of you listening might know Seamus McGillicuddy over there, who does a whole bunch of really good research around this. And people typically start with the document stage, which is, either the network is the source of truth, or the source of truth is a whole bunch of wikis and, spreadsheets and everything else. And they really need to get it into this central space. Now, Bryan, we're going to come to your super advanced use cases later because you've left all of that behind you. But, when you arrived at Dartmouth, where were you on this?
Oh, I mean, we started with network automation, just trying to, as you call out here, step one, document, just trying to gather up all the data that we have, normalize the data. Everything from, are the switches host names even related to the building that they're serving? Or is the host name spelled correctly? So we had a lot of cleanup to do. Sometimes, especially on a college campus, buildings go by different names. Do you
Right.
call it by the street address? Is there a donor name attached? What do the students call it? Various things. So kind of, we had to come up with a schema for just how we even organize our data. And NetBox really helped us with that process. It's like, listen, you've got these fields, they must be filled out, and they must be filled out consistently. So transitioning from document into model, we were able to say, all right, we've now got a ton of data. It's in a sanitized, useful format. That process alone, I'd say that took us a good year's worth of work. We were gathering stuff up from Excel spreadsheets. We had a Postgres database that we made ourselves at one point. Databases and records from our facilities team, hand-drawn maps of where cables go, screenshots from some ancient AutoCAD program. It was a ton of work. So I'm like, yes, we're now firmly in stage 3. We're automating. I do not want to say that it was an easy process to get there. It's not. If you're starting greenfield, oh boy, that's a whole nother story. But who here has the luxury of starting greenfield?
That's the promised
Very few
land.
people. Yes.
Yeah, exactly. I want to touch on document and model kind of together in this next step, because one of the things we're going to be looking at in this episode is how, when you think about documenting a network, people typically think, okay, wired devices, I get it. But there are often more things in the network. Today we're going to be looking at Mist, which is, sure, there are devices, but to talk to them, you're kind of going through this intermediate stage, it's intermediary kind of point, right? The Mist controller. But there are also other things. Like one of the things we hear all the time is, how do we get all our vCenter into NetBox? How do we get all our, I don't know, HPE OneView is a thing that came up the other day, right? There's all these other systems that maybe don't present themselves as typical devices. They've got APIs, but behind them are devices. And that's where the modeling step becomes really important, because now it's, okay, I've got this sanitized data, but how do I connect this central model in NetBox to all of those kind of disparate sources with different interfaces? And that's clearly something you've been through.
Yeah, definitely. Just because you mentioned it, VMs, our server admin team saw what we were able to do with NetBox, and they loved it so much that they started modeling their hypervisors and their virtual machines in kind of their own instance of NetBox. And they're doing their whole own automation thing completely separate from the network team. So it's really cool to see two vastly different use cases for the same software, but both driving the same mission. So
that's great to hear. I mean, another thing we see there actually when it comes to modeling is cloud. We're seeing a lot of that right now. You've got, like, the story we hear a lot is, you've got like cloud teams or DevOps teams who are used to just deploying straight to AWS, but you've got this central networking team who is responsible for IP space globally. And depending on who you ask, you get a different frustration. So if you ask the centralized networking team, they'll say, I just keep giving them /16s and they just want more, and I don't know what they're doing with them. Like, if I could only sync that information to NetBox, it would make my life easier. And then obviously from the cloud or the DevOps team side, they're like, why are these guys so grumpy? I just need to get my application deployed. So this you see this pattern all over the place.
yeah, I won't say that we've linked NetBox with our cloud yet, because honestly we haven't. But if we had more of a cloud initiative, I'll say, I think we certainly would be. We do have cloud. We have all the clouds. You can't just have one. And we do have quite a few resources out there. It's just not. We run a college campus. 99% of what we care about is on-prem. still enterprise networking. So
yeah, that makes sense. And last over here on the right, where most people are headed, Bryan and I were talking just before we started recording about AutoCon's coming up in November, and I think AutoCon is just a really good example of the excitement around network automation at the moment. As you're going to see in this episode, Bryan and the team at Dartmouth are firmly in the automate category, right? They've got all sorts of processes going on that save them time and everything else, and that I think is why it's worth going through that initial document stage, right? It's a little tricky, but it forces you to get your house in order so that you can open up all these other workflows.
Yeah, definitely. Unfortunately, I personally won't be making it to AutoCon. I really wish I could. But my colleagues and I, we attend other conferences. If you're in higher ed and you're watching this, have a look out for the Dartmouth guys who are attending the Internet 2 conference coming up in just a few weeks. So they're going to be going into even more depth about how we're leveraging NetBox for automation.
Nice. So hopefully, that gives you a sense of kind of how to position yourself as a viewer and what we're going to be talking about today. Whether you're in the document stage and you're going through that sanitization and trying to figure out how everything models into the rest of your network, it can be hard, but we're going to look at, like I said, a couple of workflows that are very firmly in the automate stage today and the kind of magic that you can get once you've done that. So moving along a bit, I want to look at this slide, which is a little busy. There's a lot to communicate here, but what we're going to do is we're going to kind of tag team this. So Bryan's brought some extra slides where he can go into like a little bit of detail around how these things work exactly. But I just want to start right at the top with painting the picture using our network automation reference architecture. So this is actually the latest version. It's actually the same as the other one, but it's been rebranded and it's been rotated a little bit. This diagram actually came out of the NetBox Design Partner Program that Bryan, you were a part of, and Felix was a part of. And we were like, what is the highest level way to sort of describe what automation looks like? And, we came up with this. And I just want to step through a couple of the bits here. We have the network source of truth in the middle. And the way to kind of think about it is, going around the right, we're pushing changes to the network. And going from the left, we're pulling information from the network. And the kind of, we're going to go into some of the workflows that this opens up. The idea is that instead of, like a traditional model where you would have your network, you would have your network engineers, and you might have a little bit of monitoring, right? And everything you're doing is SSHing into a device. It's, running lots and lots and lots of CLI commands to make anything work. The idea of including NetBox in the middle is that now we can push our intent to NetBox so that everybody can see it. We can report on it. We can connect it into other systems, as we're going to talk about later. And then when you want to push a change to the network, today we're going to be talking about Mist. You do that through automation up to the network. But then on the other side, we're always asking ourselves this question, like, okay, I've got this network source of truth, but does it still match what's in the network? Like, has somebody, I think this is a Dartmouth example, has someone plugged a switch in a lab and caused a broadcast storm, or, all sorts of other things like that?
No, so that definitely did not just happen yesterday. Not at all.
It was nice. Okay. Yeah. Well, I mean, you've got computing labs, right? So people are going to be bringing networking equipment to do stuff, and you've got a bunch of Ethernet jacks. So this kind of stuff will happen. Yeah. Over on the left, we're asking that question, like, is it, it's not just monitoring, like, is the thing doing what it should? It's also what we'd call assurance. Is the network source of truth still accurately reflecting the network? Because as Bryan just pointed out, changes can come from the network itself if you've got users or if you've got devices that fail, and not just from the operations team. And then just really quickly to touch on the reconciliation point. When we talk about reconciliation normally, what we mean is we don't just take everything that our observability and assurance tells us and stick it into NetBox via operations. There's some process in here where we look at it and we go, there's a difference. What should I do? And that's kind of super high level, what we call reconciliation. So I don't know, that was my elevator pitch for the reference architecture. How did I do, Bryan?
I think you kind of nailed it. Just to expand a little bit upon that last point there with reconciliation, ideally, yes, whatever's in your source of truth is what should be in reality. Things go wrong, problems happen. A student could plug in a switch that, oh yeah, I bought a Cisco switch off of eBay and I plugged it in, and it, all sorts of weird things can happen. But even things that are a little more mundane, like, all right, we're intentionally plugging in a new switch. It's got a LACP uplink, so 2 fiber ports. NetBox says port 0 should go to port 0, port 1 to port 1. Well, if you plug those fibers in up the other way, 0 to 1, 1 to 0, guess what? The switch will still come up fine on the network. But now what's in your source of truth doesn't match reality. You've got your fibers flipped around. And that could cause problems further down the line. Say, oh, hey, I've got, SFP in slot 0 just failed. Let me go disconnect the fiber to fix it. You disconnect the fiber based on your source of truth, and then suddenly you've now taken the switch completely offline.
Yeah.
So being able to do reconciliation from reality back to your source of truth is kind of that fourth phase of the Deming cycle that everybody loves to avoid. Plan, do, check, act. It's that validate step after checking. And yeah, it's not just, okay, well, let's just take reality and stuff it into NetBox. You have to decide as the network administrator, which one do I want to be the truth? Do I want to just say, okay, well, we plugged in the fiber backwards, let's just change the data in NetBox? Or do I want to send a field technician back out there and say, no, go swap the fibers that you plugged in incorrectly the first time? Another example is with Mist for Wi-Fi. The whole Mist interface and ecosystem, they have their own API. They're obviously storing the intended state of their APs. That's how they build their configuration. Do I just want to ignore the fact that that very well formatted, very full of detail, that rich data exists in Mist, and just say, yeah, throw it out. I want to build it from scratch in NetBox? I could, but if I've already got a network running, why don't I just extract bits and pieces of that and stuff that into NetBox where it makes sense? So I do a little bit of both. We do try to validate the network as we're continuing to operate it.
That makes sense. Yeah, that makes a ton of sense. And I like the Deming cycle, excuse me, Deming cycle analogy, because really we've got checks on both sides of this diagram. Like a lot of people will have heard of kind of CI/CD and deployment pipelines and everything else. And this isn't like connect it all up and let it automatically run, because you end up with some sort of feedback loop. Really what it is like, we're going to push something to the network. Let's do the check before we do it. And then, we're always checking over here, but even when we find something that's different in the network, this is why it goes to operations first and not straight to NetBox. You're checking there as well, because you've got that decision. Is it NetBox that needs to be updated, or is it the network? So we're going to jump into some slides that Bryan's brought to get some of the specifics here, but I just want to start at a really high level so that people have the reference to this diagram. Maybe we can just start top left, and you can give us, without spoiling the surprise you're about to show us, like talk to us about how this part works.
Yeah, so as Mark mentioned, I do have some slides that can show this off a little bit more, but really high level. Yeah, we've got our Wi-Fi network running. I don't want to ruin that just for the sake of keeping my source of truth accurate. I can't just say, I'm going to shut off the Wi-Fi for an hour while I update my database. Like, you can't do that. So what I do is I use the Mist API to extract data. And what kinds of data am I extracting? Well, for every building, every site, how many APs are there? What are the AP models? What are their serial numbers? What LLDP neighbor do they show? What switch port are they uplinked to? So as things get populated within the Mist ecosystem, I'm just leveraging that and saying, all right, feed that into NetBox. That way NetBox is still, it's a source of truth. I've really taken to calling it a source of intent. And this process that I'm describing kind of breaks that mindset. NetBox, yes, it's the source of intent, but in this case, we're feeding what's already in the network brownfield into NetBox. Once it's there, yes, that is my intended state. So if somebody unplugs an access point and plugs it back into the second port on a wall jack, yes, we now know that our intent no longer matches reality, and we can check that. So you can think of like importing a brownfield network. You're kind of skipping right ahead to that check validate step, and then you're starting the process over. And I know NetBox Labs is working on some cool plugins and software to help you import your brownfield environment into NetBox and start your automation journey at that third step of the cycle, and then give you the ability to continue in the loop as Mark is showing here. So yeah, bullet point 2 there, we create devices in NetBox for each AP. Okay, kind of boring. We're just updating our inventory. But then what does that allow us to do? It allows us to move, add, change configuration within the NetBox interface, just like we do any other piece of equipment on our network. So I have the ability to say, change the VLAN assignments on the pass-through port of an access point. If you're not familiar with Mist access points, most of them have 2 Ethernet ports, one for the uplink and one for a pass-through. The wall plate style APs actually have 3 pass-through ports on the bottom. Our students love that. I can plug in my Xbox, PlayStation, and Nintendo all at once. And then we have the ability to assign VLANs, enable, disable ports, PoE from NetBox as if it were any other switch port on our network.
Nice.
Yeah, and then also we're kind of doing the same with radio settings. I had an event back in September, the start of the fall term, where we had to stand up 20 temporary access points. Okay, great. We set up these 20 temporary access points in the gym. I needed to adjust the radio settings of all the access points in the surrounding rooms. I did that with NetBox. I just applied a tag in NetBox. I ran my deploy script, and now all the other APs lowered their power during the course of that event.
That's pretty sweet. And you mentioned a couple of things there that I want to say a little bit more about. The first was the ingestion stuff. So some of you listening and watching may have heard about Diode and Diode Agent. Yeah, so some of the use cases for Diode, it started out when people were telling us, hey, I'm a huge financial institution, and every evening I write 600,000 or 700,000 new things to NetBox, and sometimes the API doesn't stand up. So we're like, okay, we can put something in between and make sure that that's all batched and nice. The other use case was, and also I don't necessarily want to do that in the order that the NetBox API says, right? Like, if I've got a device, do I really have to create the device type, and do I have to create the manufacturer for the device type and everything else? So there's something in there that helps. But the really interesting points here are around not only capturing what's in the network through Diode agent, but also helping people to reconcile that. And I can't really say too much more, but like I'd say by the end of the year, that will be really exciting. And one of the things underneath that, which Bryan made a point earlier about, we're kind of breaking the intent model here, right? In a sense, we're pulling things from the network and pushing them into NetBox. But many of you will know that we just released branching. And one of the key use cases for branching is exactly that. Like the use case we always talk about here at NetBox Labs is I want to wake up in the morning and I want to have an email that says, here are all the things we discovered about your network last night, and here's the branch they're in. And then you can go and have a look at that branch and you can say, yep, I accept that. No, I'm going to fix that in the network, et cetera, et cetera. So just to provide a little bit more color around what you said there, Bryan. One thing I want to touch on bottom left here is event driven. A lot of people, when they're getting into automation, they whether consciously or not, they're doing things in a batch sense. And they're saying, give me all the X that's happened from any time in the past, and I'll go and figure out the logic for that. And that's a great model to get started with, especially, to do event driven, if you're comparing systems, you kind of need both systems to be event driven sometimes. But you guys have really learned into event driven. It seems like not only with NetBox event streams that I was aware of, but also with Mist.
Definitely. We've been using Mist's WebSocket and webhooks since almost the very beginning of our use of their product. We realized early on that if we're doing batches of updates to our source of truth or to our operational config, say we do a batch once a week. Well, guess what? We're a week behind. It's hard to it's hard to keep up with it. And then suddenly it's like, oh yeah, well now the batch this week is 400 items instead of the usual 2 or 3. Now I've got to burn an entire day just doing manual data reconciliation. By doing event-driven automation reconciliation, we're able to say, all right, whenever something changes, we're able to react to that change, gather the data, and handle it consistently and in a timely fashion. So that way it's like, oh, well, I didn't get to the batch last week. I'll have to do it first thing on Monday. There's no more of that. It's, we've really leaned into event-driven automation in order to honestly save us time. We're trying to maintain the source of truth that's in NetBox, as you've been describing, but also, hey, when we change something in NetBox, like I just flipped this device from being in an active status to a maintenance mode or a decommission status. Okay, well, what does that mean? I have to go and tell my network monitoring system that, hey, stop alerting for this. I might have to tell my nightly operations, hey, don't try to deploy config to this overnight because it's going to fail. Different notifications to end users even. I'll touch on that in a bit coming up. So we're able to say, at the drop of a hat, when something happens, we're able to update all the pieces that care about that information all at once.
The analogy I like here is it's like doing your taxes. If every Sunday you spend half an hour getting ready, then at the end of the year, it's just a dream. But if you do it the week before, like everybody does, well, you know how that feels already. And it's like back in, I guess, 2010, 2011, 2012, continuous delivery was becoming a big thing on the software side. And one of the things they always used to say was, if it hurts, do it more often, because it'll force you to improve those processes and everything else. And, the difference, like Bryan says, is, do I want to go and reconcile the 500 or 600 changes that have happened in the last week? Or do I want to get a Slack notification that says this has changed? What would you like to do with it right now? And that's, that is what's possible, but obviously Dartmouth is very, very advanced and it takes a while to get there.
Or even engineer out that Slack notification. If
Right.
you can programmatically instruct your automation, when this happens, this is what I would do as a human, just have the script do that for you. Obviously notify a human about the exceptions to the process. But if you know that, all right, well, when I see a VLAN change from a campus data port to a printer port, do I care? No, just let it happen, But if I see it say, hey, it changed from campus to point of sale PCI compliant, then you might want to get a human involved just to say, yes, I've set eyes on this. I've confirmed that this is an appropriate change to happen.
I think there's a risk of us talking about AI here, but let's save it for the end because I think this is where AI ops comes in a lot. But I'm no expert. What I could do now, Bryan, for this part is hand over to you, and you show us a little bit more of how it works under the hood.
So, as Mark just mentioned, AI. I can feel proud of myself for today. I wasn't the one to bring it up. If you've heard of Mist, you've certainly heard of Marvis. It's their AI assistant. It's the big marketing buzzword from the Mist product team, and it's more than just a parlor trick. It's actually helping me run my network. I took this screenshot just earlier today. You've probably seen something very similar to it in all the marketing material if you've looked at it. And what Marvis does, it's machine learning for those check and act phases of the Deming cycle. The reconciliation, the validation. And what it's doing is it's constantly checking the network, looking for drift from intent or problems that just arise. You can have all sorts of issues in a network that have nothing to do with drift from intent. In this example here, Marvis has detected, hey, I've got 15 bad Ethernet cables in my network. Ooh, 15, that sounds like a lot, but guess what? I have 65,000 switch ports on my campus. 15 is a very small number. So honestly, I feel pretty proud of this statistic. But what Marvis is doing is it's looking at all the error counters on all the interfaces and saying, hey, here are 15 potential problems that we found that if you go and resolve this or fix the cabling, it will actually improve your user service. going to be alerting you to every little problem that exists. You know, if you look at my traditional SNMP based network monitoring, it looks like the world is on fire. There's all sorts of problems. Marvis is leveraging that AI technology to say, hey, here are the top things that are actually causing your users possibly a. So what I can do with this is every time Marvis says, hey, you've got a bad cable, or in this other example, you've got a couple of switch ports that seem to be missing VLANs that should be tagged. You leverage automation, leverage that event-driven, webhook-based interaction between Mist, NetBox, ticketing systems. And what I'm able to do is I'm able to semi-automatically as well as automatically generate tickets for my field technicians saying, hey, Marvis detected a bad cable. I'm going to pull data from NetBox. Here's the switch port, the patch panel, the telecom room number, the building. Here's how to get there. Here's the key that you need to open the door. I'm just compiling all this information and shoving it into an API call to my ticketing system. That way, I've now saved my technician probably 30 minutes worth of work looking at that all up by hand.
That's really interesting because I guess what's happening behind the scenes is, I thought the SNMP example was perfect. It's probably a ton of different things, right? Syslog, SNMP, all sorts of notifications. And what Marvis is doing is it's correlating those and saying what's actually going on here. So instead of maybe 100 different alerts, I'm getting the one that matters. Is that right?
That's absolutely right. Marvis is bubbling up the errors or the problems that it's detected that actually matter. And it's recommending that you take an action, that's this whole Marvis action screen, because it will improve the operation of your network. Obviously Marvis is software. It can't physically walk into a telecom room and reseat a cable or swap out an SFP. Maybe we'll get there, who knows? But today it can't do that. The best it can do is say, hey, operator, I would like you to take this action. It will make your network happier.
Well, I did wake up to Twitter full of Elon's robots this morning, so maybe he's got an answer for us in the future. We can get those guys down in the DC.
I haven't looked at that stuff yet today.
It's not even slightly worrying.
I'm sure it's not. So yeah, I mean, so Marvis is not only it's filtering out the problems that don't matter, it's also able to look at the incoming data and say, is this actually a problem? If I look at an interface, say a switch port has been up for 365 days and its error counter is 1, is that actually a problem? Over the course of a year, the switch has seen 1 receive error. I'm not going to go and do anything about that. Yep. Neither is Marvis. What it's going to do is say, hey, over the past week, we've seen this error counter continuing to climb. This looks abnormal. It's able to correlate that and say, hey, this is actually impacting throughput or latency for your user traffic. So it bubbles up an alert and says, hey, please go fix this.
Got it.
So in Mist, you can subscribe to many different kinds of events. This is what's in the graphical user interface. If you use the Mist API, there's a couple more that you can subscribe to as well. So I mentioned device events like bad cable, missing VLAN. I also subscribe to device up down. So when a new access point joins my network, say I'm installing access points in a brand new building, or if a device reboots for some reason, I have a script that's running that is listening for those up-down webhooks, and it's able to run a process to help with out-of-the-box provisioning. Kind of a zero-touch process. And what we're seeing kind of in the middle here in the green text is the resulting log file from that script that we've written. It's at the very top there, we got this notice, hey, new device found, here's a MAC address. Does this device already exist on our network? Is it the first time we're seeing it? In this case, it's the first time we're seeing it. Okay, right. First things first. Before I do anything else, let's make sure it's running the firmware that I want to run in production. We look up the AP model based on this webhook data. We check the firmware version by making a query to the Mist API. And then we say, hey, does this match the target firmware that we've configured in our source of intent? In this case, it matches, no upgrade needed. If it doesn't match, one API call to Mist, please upgrade the firmware, let me know when you're done. We then fetch the LLDP neighbor. What switch is this new access point connected to? Okay, Mist tells us the LLDP hostname. Let's go to NetBox. Is this a switch I know about? Is this one of my switches? Or did somebody take an AP and plug it in at home? Or in some other building that we're not ready to activate service in yet? So we talk to NetBox. We say, hey, Mist is saying we've got this new access point. It's connected to this switch in this port. NetBox, what do you know about this? NetBox says, oh yeah, I know about this switch. It's in this building. Okay, Mist, please put this new access point into this site in your system. So we're using NetBox to drive the intended config in Mist. Mist makes that move. We're able to say, place it on a map. Based on the name of the switch and the switch port that we get from NetBox, we say, hey, this switch is serving the first floor of this building. Mist has a mapping system, so you can see a floor plan of your building, where the access points are. It ties into their whole indoor location services, which I'm not even going to talk about here. But we're able to say, hey, throw that AP on the map for the first floor. Full disclosure, we're not putting it exactly where it belongs on the map just yet, but we can. Using using tools like Hamina, Network Planner. We could leverage their system and say, hey, from the designed Wi-Fi, we can then reference Hamina's data and say, Hamina, NetBox, Mist, we know exactly where that AP should be on a map, and we've now correlated the MAC address and the switch port. Beautiful. That's probably a solid 15 minutes of work for each access point if an engineer were to have to do that manually. We then make some other provisioning changes, say, hey, we want to turn on BLE beacons. We want this access point to be broadcasting our EduRoam and our public Wi-Fi network. Tell Mist, yep, please turn on those SSIDs. Boom, we're done with this device.
Yeah,
And if you look,
cool.
if you look here, 5843, 5902. This whole process was done in, what's that, 25 seconds? Did I do the math correctly?
Yeah, I think so. Yeah. 17, no, 15, wait, 17 plus 2, yeah, 19 seconds.
19, yeah, under a minute is what I'm getting at.
And I think the thing about this, right, is it's not just about the time. Like you could say, well, I don't care, 15 seconds or 15 minutes, who cares? But the thing is, one, if you've got a lot of these, and two, how likely is it that somebody will make a manual mistake if you're doing all of this manually? I think that's how this starts to like really blow up the value.
Yeah, one of the major benefits of network automation is consistency. You're no longer typing in data by hand. Spelling mistakes, assuming you spelled it right the first time, spelling mistakes are no longer an issue. It's like there's no more, oops, I clicked the wrong building, and now I've provisioned this access point for the entire wrong configuration. I have to completely wipe it out, factory reset it, get the paperclip, and start the process over. None of that. You're doing it right the first time, every time. And then this scales as well. It's like, so what? You provisioned a single access point. Well, guess what? Go to that link that I put down there at the bottom. I used this exact process to install 2,000 access points in 12 hours. I've written an article. You can read the whole story there. This is how I did it.
That's awesome. And I think the other point about consistency with automation that those who are new to automation sometimes don't fully appreciate is when things are consistent, it makes the debugging cycle so much easier. Right? Like debugging what a human did is very difficult because they have to remember what they did. And they don't because they typed in 400 CLI commands in the last hour. With an automation, sure, it can go wrong, but you want to know what it did? You just look back at the code and it'll tell you what it did. And this really helps not only when it's deployed, but actually getting it to that stage.
Yeah, and and even if there is a bug in your automation, fixing mistakes becomes so much easier. Okay, well, I made this one mistake 1,000 times. Great, I just write another script to correct that one mistake and repeat it 1,000 times. My colleague Felix has spoken previously about automation eliminates entire classes of troubleshooting, like total categories of what could have gone wrong. No longer even need to be part of your thought process. Like, could it be, oh, did somebody fat finger the IP address? Did they click the wrong floor plan in the management software? There's none of that. It's being done the same way for every single device.
Yeah, and the training thing as well, because sometimes if things keep happening badly manually, now you got to retrain everybody. Retraining is very quickly when it's Python script.
Yes, it is. So this is the process that I used back in 2020, as my article alludes to. The folks at Mist, I forget who said it, but the highest form of flattery is copying. Well, Mist has heard about what I've been doing. This is now baked into their product. So if you're thinking, wow, I'd really love to get to that total self-driving process, but I don't know Python, well, guess what? You don't need to know Python anymore. If you're a Mist customer, this is built in out of the box now. You're able to do automatic upgrades and automatic site assignment and automatic AP naming just based on LLDP name or a handful of other attributes that are present in those event-driven webhooks.
Wow. And that from a NetBox perspective, you would, I suppose, have NetBox tell Mist something like things like its location data, and then it would automatically generate like all of that stuff that you needed, or would it be kind of a two-step process?
It's probably a few more than two-step process, but it's a two-way process. So here's an example of another Mist access point, and it's record in NetBox. So what do I have? It's pretty bare bones on this screen. All right, we know the site that it's in, we know the room number, the device type. I didn't bother. This was before I cared about serial numbers, but you could put serial numbers here if you care about that for asset tracking. Is it active or not? Is it still in a pre-provisioning plan status, or is it actually providing service? Obviously, it's an access point, the role of its Wi-Fi. You could put all sorts of other things in here. And then you can say, leverage the other features of NetBox and say, I want to apply a tag to this. This is the Wi-Fi dorm tag. This is an access point providing Wi-Fi in a dorm room. That tag by itself doesn't mean anything else. It's just got a little purple sticker on it. But now my other automation process can see, aha, that access point has the Wi-Fi dorm tag. Maybe that means I should make some certain assumptions about it. You can put in comments as well. By modeling these access points in NetBox, I think I mentioned earlier, I'm able to configure these Ethernet ports, these pass-through ports, as if it were any other switch port on my network. I now no longer have to train my staff. Here's how you change a VLAN in Junos. Here's how you change a VLAN in Cisco. Here's how you change a VLAN using the Mist UI. No, you just go to NetBox. Here's how you change a VLAN, period. Behind the scenes, NetBox's source of truth, that source of intended state, well, our automation is just rendering out configs in Juniper, in Cisco, or even the Mist API payload format. We're also able to apply config contexts, and this is where that Wi-Fi dorm or other tags apply. When you see this tag, this sticker that's been applied to a device, what does that mean? It means you should overlay this config on top of whatever you've rendered. So in the case of a dorm room, we want to turn off the LED light. If you've ever tried to sleep in a room with that bright blue light
Yeah.
shining,
Right.
they can actually be fairly bright. We get a number of complaints from students, well, we used to, saying, "Hey, the light on that box is too bright. Can you turn it off?" Or
Mhm.
we go in and we find that they've put duct tape over it. So we just turn them off. It's made things a lot easier for everyone. We also say, "Hey, let's set some radio parameters based on that tag." Obviously, good Wi-Fi design channels 1, 6, and 11. But here I also say power between 3 and 5 dB. I want to have really low power because if I'm a student in a room, I want to connect to the AP that's in my room, not the one in the hallway.
Mhm.
So we really reduce the Wi-Fi coverage cell sizes to improve performance. High density Wi-Fi, there's whole lecture tracks on how and why you would do things like that. And then any other config that the Mist API can leverage can also get applied here.
And would for the Wi-Fi dorm configs, for anyone who's watching this and not familiar with config contexts, these can actually be generated from Ginger 2 templates, right, based on
Correct.
data that's in NetBox. How, like, which parts of this are variable and which parts of this are static for you?
Uh, I mean, so everything you're seeing here in this dictionary, these are all everything is variable.
Got it.
Do we generate it from the built-in sets of data from NetBox? Do we generate it from config contexts? Do we have Jinja templates that are also feeding into it? The answer is yes. We use all of these different mechanisms in various different ways. And then at the end of the day, it all comes together and renders out the one config that gets pushed to the device or to the cloud or to the hypervisor, what have you, whatever device you're talking to. Um, and that's what this next slide shows is, all right, now behind the scenes, I've got a Python script that's doing CI/CD. This is running. We run our deploy script every night, so that way any changes that were made in NetBox get pushed to the device every night. This is a very shocking thing for people who haven't gotten to this step yet. It's a very big culture change, but we've proven that our automation is reliable, it's consistent, and by forcing these configs to apply every night, it's also kind of forced our culture to turn. And we're now at a point where if it's not in NetBox, it's not on the network.
Yeah.
I think that's a very fantastic state to be in. Obviously, I'm there. I can say that. But it was also a very long road to get to. NetBox is a source of truth, source of documentation. I can't just go and make a change and not document it in NetBox because now I know it's going to be overwritten overnight. So
This fits a pattern that when I was at AutoCon 1 in Amsterdam, we got the bus to like the party, and I was sat next to a Belgian guy who I will who will remain anonymous, and he said, similar story, right? They finally got to the point where they're pushing the configs. For them, it's not every night. Whenever they detect anything's different, they push it. They push what the intent should be. And he said this is really good at discouraging people from SSHing into the devices because it's worthless, right? Like whatever they change, we'll go back to what it was, 10 minutes from now, and that sort of it helps people to get into the process, right? Helps to remove. We said earlier that change can come from the network itself. And before you're doing any intent-based automation, that's actually where it all happens. But really, you want to get that out over time, and doing stuff like this can be really useful.
Yeah, that's exactly the same here. We're not doing event-driven deploy just yet. We still feel that we need to tweak our kind of our guardrails, our validation step, and say, hey, is this change safe to apply automatically? For example, adding a VLAN to a trunk port, pretty
Mhm.
harmless.
Yep.
Removing a VLAN from a trunk port could cause all sorts of chaos. So we have a whole nother part of this automated process that runs every night that says, hey, let's look at the diff. What has changed in this config? And is this safe to automatically apply or not? In this example, I've made no changes to this access point. I ran this script earlier today and took a screenshot. The only thing that's changing here is the timestamp from when the config was generated. I haven't made a change to the config on this access point since August. I'm not going to push a whole config just to update the comment. I don't need to do that. So
Yep.
it just says, yeah, there's nothing of value to actually change here. Let's just back out and disconnect.
And this, I won't spend too much time on this, but we spoke earlier about how NetBox branching helps when stuff's coming in from networks. This is another perfect example because what you could do here is you could put your change, and I think you guys actually do this. You delegate certain tasks to service desks, like adding a VLAN, so that they can do the work, and then what you get is just the change that should be there.
Correct.
One of the patterns we're starting to see people adopt really quickly with NetBox branching now that it's out is put those changes in a branch, run any tests you need to do against that branch. Maybe you've got to get them reviewed by a peer, but the changes landing in there could be generated. It could be generated from a service desk portal or something else. And then you kind of fall into this process again, where you say, well, what are all the open branches? Like what's all the intent that we haven't made the intent yet?
Yeah.
And go through those, apply those to the network, update the intent. So it's interesting on both sides of the reference architecture.
Yeah, and we're getting there. We do have non-network engineers who are making changes in NetBox. We've empowered them to do that. We want to open that up to the entire help desk staff. Right now, we've got a handful of power users that we've kind of entrusted with the keys. But if we can say, yeah, the changes that you're allowed to make are harmless, that improves not only the perceived quality of the service from the IT department, but the time to remediate. Say I'm a professor, I put in a ticket and says, hey, I have a printer, I plugged it into the jack, it doesn't work. The service desk can now go into NetBox and say, oh yeah, we need to put that jack on the printer VLAN. If they can do that and say done, they've now closed that ticket out and provided the requested service in a matter of minutes, rather than, okay, well, we have to escalate this to network engineering and Bryan will get to it in a day or two because it's not very high priority. And, we'll let you know when the change is made. We're even thinking for some things, what if we just take the help desk out of it entirely? How can we enable user self-service for some changes? That's something we're actively thinking about here at Dartmouth.
Yeah, and I just wanted to add one point about immediacy. Like, one of the things that we hear about that happens is if it takes, let's say, multiple days to deal with a ticket, the intent of the ticket will change, right? The person requesting it will have new ideas or extra context. And then what happens is it becomes more complex to actually apply those tickets because their context has changed. They're dealing with some kind of thing as well. Whereas if you can do them immediately, you get the ticket done, it's done. And if they change their mind at some point in the future, well, you do that immediately too. So there's all sorts of benefits to this immediacy.
Yeah. Or worse yet, shadow IT.
Right.
Well, the help desk didn't get back to me for like 3 days, so I went to Best Buy and I bought a 4-port mini switch and a 50-foot cable, and I put the switch in behind the printer from the office next door, and I ran a cable through the drop ceiling myself. I don't need this ticket anymore. Just close it.
And BPDU guard is not switched off.
Yeah. So being able to provide faster, better, and more consistent service to users, it helps change that cultural mindset of the IT department being slow and useless and grumpy all the time. Because guess what? I'm not dealing with printer move add changes. That makes me less grumpy. Not gonna lie.
Well, less printers in your life.
Less printers, less grumpy.
Yeah, nice. Well, this is awesome, Bryan. And we're gonna come back to Bryan's slides, I believe, after the next slide of mine. So let's just sure. Okay, so we've seen some of the specifics here and got a ton of really useful information from Bryan about how this bit works. I want to jump to one specific use case, and actually the use case that got my attention to reach out to Bryan to say, let's do this episode in the first place. It was this tweet up here. My colleague CEO, Chris, picked up on this and put it out on LinkedIn. We all loved it here at NetBox Labs. Upgraded 988 Juniper Networks campus access switches, just 3 mornings using NetBox. Maybe now that everyone's familiar with the reference architecture, you could tell us kind of how this specific use case came about and how you feel about solving it.
Yeah, so before anybody says, well, Mist has wired assurance that does this for you, why are you doing this with NetBox? Again, we started this journey before wired assurance was even a thing. So if you're a Mist customer, this is out of the box with Mist. Still pay attention. I'm going to talk about how we kind of got there. So yeah, being able to do things at scale is another huge benefit of automation. If I have to upgrade firmware on one switch and I can automate that, I can then run that 988 times and upgrade my entire campus in roughly the same time period as it takes me to do one. Automating firmware upgrades also allows me to do upgrades more frequently. One of the points of pride with network engineers is, oh, I've got a router that has an uptime of 10 years and 7 days. That's awesome. I think, oh no, that's horrible, because you haven't applied security patches to that router for 10 years and 7 days. That is a terrible state to be in today's cybersecurity ecosystem. We need to be able to install patches much more quickly. Once a year at a minimum, I would say. We're doing it multiple times a year. Whenever there's a patch that needs to be applied, I take advantage of every maintenance window I can get my hands on and say, all right, let's do patching. Winter holiday break, spring break, over the summer. Being a college, we've got a pretty consistent schedule. I've got roughly 4 solid maintenance windows between every season, every term, where I can go and do big changes like this. And you know what? Honestly, upgrading firmware is not even a big change anymore. It takes a couple of hours in the morning and I'm done. I did 988 a few weeks ago. I just did another dozen just this week, and why didn't I just do them all at once? Well, being able to automate, being able to leverage NetBox has allowed me to be more flexible in when I'm doing maintenance. It's not just, oh, we got to shut down the whole campus to do upgrades. No, I can say, well, I can't do these buildings because there's special events going on. Or, in this specific case, our business school actually started classes before the rest of the college. So while everybody else was still enjoying the last week of their summer break, the MBA students were already hard at work. I couldn't just shut down their network for 6 hours one morning because they're in the middle of studying. They have early morning classes. It was, from a business case, it wasn't acceptable to do that. So, all right, I take advantage of the next maintenance window and I just run the same process again. I didn't have to think about it and spend, okay, how am I going to do this? No, it's the same process I do every time, just with a different list of switches.
It's interesting that you bring up maintenance windows because well, I spoke to you about this as well. You remember I put out all those blogs earlier in the year, and I was speaking to a whole bunch of people about their networking practices. And maintenance windows came up as like one of the sort of blood pressure raising, gray hair inducing moments of everybody's lives, because there's a few different things going on. There's like business wants to get a lot of things done during the maintenance window. Network engineers would like to do a little bit less. And this whole relationship, a bit like the relationship we spoke about earlier between users or cloud teams and the networking team, it all comes because often we're not really sure it's going to work. We don't have great certainty in our automation. So we're kind of guessing what's going to happen in that maintenance window. We want to have as little as possible in it, and we want to have as much time as possible because we need to be able to get back to a good state. But as you start doing this, like you said, I just did 12 this week, these become kind of non-events.
Exactly. I wouldn't I wouldn't say that it's a non-event every time. You know,
Mm.
every year something happens. Oh, there's an edge case that came about over the past year's worth of operations that my automation didn't account for. I found one of those back in September. Oh, look, we have a virtual chassis where the switches are stacked in a ring. Well, the bottom switch wasn't connected to the top switch, and that caused a problem. My automation was making an assumption that the ring was complete, and it wasn't. Guess what? A few lines of code later, I've now included that as a health check before and after the process. So it's a work in progress. You know, this is never going to be finished. I'm testing things out in the lab, running them in production, and fine tuning as I go. But I know that I've engineered out so many of the edge cases and the problems that I've encountered that now for 99% of my devices, I don't even worry about it. You know, we still need to do this during a maintenance window because guess what? One or two switches every time doesn't come back properly. You still got to do it. It's still a maintenance activity. There's still work to do.
Got it. Well, we've got the high-level view here. Brian's already touched on, some of the checks, additional checks that have been added over time, and I think we're going to jump back to your slides to take a look at what does this really look like when you're running one.
So I'll show you the exact process that I used just earlier this week. One of the scripts I've written leverages, obviously, NetBox to fetch the list of switches that I want to run in this batch. So I'm able to use the NetBox API and filter based on what site or site group the devices are in, what the role of the device is. Is it access layer? Is it core, distribution? You name it. And what the status is. Hey, I only want to upgrade firmware on switches that are active right now, not ones that have been decommissioned. Obviously, that won't work so well. So by running a command like this, I'm able to say, hey, give me a list of all the access switches in active status that are in the Tuck School of Business site group. Here we go. Here's all the host names. What do I do with that? I stuff that output into a file in Linux, or I could do this all in one go with pipes and xargs and all that, which is actually how I do it. But for the sake of the demonstration, let's stuff this list of switches into a text file. Then I can use that text file to say, generate maintenance notifications. Okay, I've got a list of host names. That doesn't mean anything to my end users. What I need to do is I need to reference those host names to our facilities database and get the proper official name of the building. So when I'm publishing a maintenance notification to the public or to emails, I'm not saying, switch Actmeyer CO21-SW will be offline for maintenance. That doesn't really tell me anything as an end user. So I'm able to say, hey, which buildings are served by these switches? And I'm going to call out one example here. You'll notice that there's no switch in here named for Pino Valenciennes Hall. That building is actually served by its neighboring building, Actmeyer. And yet, when I generate the maintenance notification, I'm able to inform users in this building that their network will be interrupted for maintenance. So being able to correlate, based on NetBox facilities databases, and then also publish to our public-facing status page a consistent, clear, and complete maintenance notification. Back when I was doing this manually, if I forgot to list a building in this maintenance notification and I rebooted switches for a building, I would never hear the end of it. You didn't tell me my office would have no Wi-Fi. Sorry, I forgot your office was served out of that switch stack. Now I don't worry about it again. It's automated. It's very consistent.
I was just going to say this is a great example of, earlier we looked at documenting and then modeling. And when we think about modeling, we really think about modeling the data model and also how does it relate to other systems? And this is just such a great example of, sure, we've got the name of a switch, but really what we need to know is the human-facing thing because we're going to be talking to some other system, in this case, a status page.
And in order to talk to status page or to talk to our facilities database, they don't know the names of the switches either. So we use foreign keys to interact with these other systems as well. And we have custom fields in NetBox that store the foreign keys for every site or every device just to make that integration easier. So. And you might think, this what does this have to do with network automation? Well, if you're actually operating the network, everything. This is boring. You're not generating config, but I mean, who here watching this webinar has to create human readable notifications? I do. Probably most of everybody else here. There's also been talk among the service provider industry. How can we come up with a consistent format, maybe a JSON file, indicating start date, end date, start time, end time, circuit ID, affected customers? How can we programmatically generate these maintenance notifications? If you work with your WAN circuit providers, you've certainly seen this. Every provider has a different email template that they use. Sometimes they provide the data in an inconsistent format, and you've got to go like, well, they gave me the circuit ID. Which building is that for? What branch office does that serve? No more of that. Once we get to a point where providers are providing essentially webhook style notifications with sanitized, consistent data, we can generate these maintenance notifications ourselves as well. Obviously, internal to their operations, they're doing this. At least I hope they are. Why not provide that to the customers as well?
So this is, I think this is really important for anyone who's kind of at the beginning of that phase, not just getting into network automation. You'll if you go Google network automation, you will find all sorts of scripts to like pull stuff from the network or to update a config, and it's really important stuff. But where it gets more important, where it gets more valuable, to be honest, is when it starts to interact with the users of the network like this. So it's not just can I update all my devices more quickly, it's can I do it in a way that follows the process, has compliant configs, lets everybody know what's going to happen. And it's a really, important to set the foundations and then build up from there. But I think really the action and the value happens when you start talking to your users.
Yes, I mean, because the whole reason we operate a network is to support the users, to support the business. And as much as all of us would wish there were fewer users, well, then there'd be fewer network engineering jobs. So you got to play in the same sandbox. Might as well make it easier for everybody. Just to continue on with my story here, that text file, that list of switches that I've saved, well, guess what? Those are the switches that I want to upgrade firmware on, right? So I have another Python script that leverages that same output from that NetBox script and says, hey, I want to update firmware on these switches. So I have a Python script. It's 1,000 lines of Python. This is that process that I've been chipping away at. Every year I add something to it. I put in a new edge case or a new health check. And it's pretty, knock on wood, pretty bulletproof at this point. Earlier on, that wasn't the case. Again, network automation at a scale like this is a very long and difficult road. But once you get there, the goal is so worth it. So I feed that text file into this script. Again, it pulls data from NetBox, like, all right, what's the model of the switch? All you've given me is the host name. What do I do with that? What version software do I want to apply? So I can say, all right, well, NetBox knows it's an EX3400, 48 ports, and it provides power over Ethernet. Aha, that tells me that I might also need to upgrade the power over Ethernet firmware in addition to just the operating system. So my script will take that into account. Oh, what version of the operating system? Well, I've set the Junos version as my intended state in NetBox. So my script says, aha, NetBox says this is my intended firmware version. I better install that file. The script goes through. I love the concept of a state machine. So a lot of my automation is state 10, state 20. I blame it on the old basic programming days. 10, 10 go to 30, based on if then else statements. It's
My colleague
it
Bill
works for me.
will be very happy with that. Yeah. Okay. Cool.
So my process runs, and this is just the first dozen or so lines of output from it. I'm not going to bore you with all of it, but it connects to the host. Yes, we're actually able to talk to the switch. We use the netconf API that Junos provides for every one of their devices. We've completed state 10. We're able to talk to the switch. Yay, woo! Let's keep going. Let's confirm that the model the switch is reporting matches the model that's in NetBox. Things could go horribly wrong if that's not the case. Might as well check while we're here. Set the target version. Does the target match the running? In this case, no, it needs an upgrade. Move on to step 30. Log into the switch. I believe So I use a little bit of everything. I use Juniper's PyEZ library. I use Paramiko, NetMiko, Scraply, all of it. Best tool for the job, right? So I'm able to send some interactive commands to the switch. Do I need to copy the file to the local storage, or does this switch support downloading it via FTP? It does it with FTP. I can skip the local copy.
Yeah.
And then run the whole Junos firmware install process. I won't get into that. They've got tons of documentation on it. It runs, it does storage cleanup, it does health checks, it checks, do I need to upgrade PoE or CPLD firmware, all the ASICs inside. Sometimes there's an additional update. It reboots the switch. When it comes back, it checks, all right, NetBox says there should be 4 switches in this virtual chassis, or in this case, 3. Size is 3. NetBox says 3. Does the switch report 3? Yes. Great. Is the ring complete? Does every member in that ring talk to each other? Yes. Awesome. Complete. Am I providing power over Ethernet on all members? There's a Junos command to display that. Yes. All healthy? Good. And I just go through all these health checks that I would be doing manually if I were to be doing this all by hand.
Yeah.
I've automated it. And I just look and say, yep, does everything match? if I use a regex, does it have the string of text that I'm looking for? Are there any error messages in the log file that said failed or error or something that's other than good and succeeded? Call it good. And then this actually sends me a Slack message that says, yep, firmware complete. So I kick this off with a cron job. It starts at 3 in the morning. I'm still sound asleep in bed. I wake up at 5 a.m. because it should take 1 hour start to finish, even for our biggest switch stacks. 1 hour. All right, let's give it 2 hours. 3 a.m. I wake up at 5 a.m. I look at my phone. Slack says, yep, process complete. Great. I'm going to go back to sleep for 2 more hours. That was my Thursday morning this week.
Nice. I guess one improvement there could be set off the alarm on your phone if it didn't work so that you can theoretically just sleep straight through.
Oh, yeah, that's a good idea. I mean, and in addition, all behind the scenes, our network monitoring is continuing to keep tabs on these devices as well.
Right.
So, I mean, as the on-call engineer, I would have gotten paged anyway if a switch didn't come back online. But
Yep.
yeah, being able to bake that into my entire process, that'd be certainly a worthwhile improvement. So that's the short version of it. Again, this is not something I whipped up overnight. It took hours and hours and hours of testing in a lab using real hardware. I feel bad for my lab switch. I've upgraded and downgraded and upgraded and downgraded that switch so many times to build this script that its flash is probably on the verge of bursting into flame right now.
Yep.
But again, the goal is worth it. And also, again, if you're a Mist wired assurance customer, you don't have to do this. They've done it for you. They've got a nice upgrade firmware button you can just click.
Well, that's a really nice point for us to dig into just a little, because obviously you're running wired outside of Mist, and then you're running APs inside of Mist.
Correct.
For anyone who's not using Mist, or let's say not using Juniper, and they've still got a bunch of wired devices, this is still a great blueprint for how to go about your automation and get these kind of workflows.
Yeah, and by doing things with NetBox and with our own automation, this allows us to be vendor neutral. I love Mist. I love Juniper. Don't get me wrong. I feel that they're the best product for our campus at the moment. Should that change in 10 years? Who knows? There could be a startup that forms in the year 2030 and it just blows the socks off of every other vendor. I can't predict the future. But if and when that happens, you know what? I've got my process baked. I've got my data in NetBox, my intent in NetBox. Who cares what vendor equipment I'm using? If you're here listening to this and you're from Juniper, you're probably like crying and screaming. Just cover your ears for the next 3 minutes. I'm doing everything I've talked about today. I'm doing cross-platform. Yes, I'm rendering Juniper configs, but you know what? I can also render Cisco. I'm rendering MikroTik configs. Of all things, I'm rendering config for Netgear. Our classroom audio video folks are using Netgear switches. Business case, get it. It's actually a great fit for their use case. I don't blame them, but we're able to automate those as well.
All right, so that kind of brings us to the end. Bryan, this has been amazing. I just want to kind of summarize, mainly for my own benefit here, because I've got a few additional questions. So we looked at different levels of maturity from documenter through modeler all the way up to automator. And obviously you guys are firmly in the automator section right now, but you gave some really interesting information about how getting through that document and model step it isn't a free lunch. And even the automation step isn't a free lunch. A lot of lab work, a lot of trying this out. But I think once you get through it, the results when you have intent-based networking like this with NetBox in the mix, with all of these other systems, obviously speak for themselves. We looked at how you're doing it specifically for Mist. And I think one of the things that was really interesting for me in there was often when we're explaining that maturity model, people get the document bit and they get the automate bit. They don't get the model bit so much. And just in this episode, you've spoken about how this talks to facilities management tooling and status pages and all this other stuff. I mean, I believe you're also using location information in NetBox for E911 systems, which is outside the scope for this. Yep. Yeah. So that modeling stage, super important. Also tricky because what you're asking yourself is data model questions, right? Like if NetBox says X, what does it mean in the other thing?
Exactly. Yeah. There's a lot of philosophical hoops to jump through before you can get to a state like this. And Mark, I think if there's like a show notes or something that you can put in alongside this, there's a webinar that Felix and I had done with you. I think last year was it, where
So
we talk more about our about that part of the process, where how what does the data in NetBox look like? How do we distill it down into something that our automation can actually use? We call it the fact, render, deploy, or apply process. So
we
there's
can absolutely add that to
there's
the
a whole
video.
other recording.
Yeah, we'll add that to the video and and to the show notes afterwards. I've got one other quick question for you.
Sure.
We touched on the idea of informing operators about stuff. I made a joke about setting off your phone alarm. You talked about pages. You talked about Slack as well. Obviously, one of the things that you've really focused on outside the automation is making sure that the users are updated. But we didn't really touch on how you interact with this. And I wondered if maybe you could tell us a little bit about what sounds like a ChatOps approach you've got.
So Slack has a pretty robust API. You can send it a REST style, you know, post notification, and it'll make a message appear into a Slack channel or a DM. I think Teams has this as well. Back in the day, you could have just done this with IRC. Pick your poison, whatever chat platform you're using, figure out how their API works. If for nothing else, then just how do I automatically send a message to a person? That is such a huge quality of life improvement for myself and my team. I don't have to log into VPN, sign into a dashboard, check out my credentials, press my two-factor token. Like, no, I just look at my phone, upgrade complete, great. Why can't my automation interact with me just like the rest of my team does? So I would say look into that. Email used to be the way to do it 10 years ago. Chat is more, it's faster. It's a little more flexible. But yeah, if you're really using email in your organization, all right, figure out how to automatically send an email message. If you're using notification systems like OpsGenie or PagerDuty or any of those others, they've got APIs as well. Figure out how you can hook into that. So that way, yeah, if there is a problem, don't just send me a Slack message, blow my phone up and make sure I get out of bed. Your automation can do that just like your network monitoring systems do.
Nice. All right. Well, Bryan, that's all we got time for today. I want to say another big thank you for taking the time to prepare this and to come and share with us. I think we're going to have more of these in the future, not scheduled right now, but E911 is an increasingly important topic I'm hearing. We've got multiple people in the community now working on different approaches to this. So that's one thing, if you're watching at home, to be on the lookout for. We've got a few little links here. Obviously, I'm very accessible. You can use my email. If you want to get in touch about any of this, you can go to netboxlabs.com for NetBox information. And then over here, on the right for Bryan, 3 underscores. Make sure you get that right. Otherwise, you'll find somebody else who may not be telling you interesting networking things. Second thing to call out is the NetDev Slack. So if you're not familiar with the NetDev Slack, you can go to netdev.chat, and that allows you to sign up for the Slack, which is predominantly NetBox, but loads of other good stuff in there as well. There's lots of other open source tools that all kind of hang around in there. Thousands of people discussing NetBox and network engineering and all sorts of other things. You can find Bryan in there. And then lastly, I will recommend Bryan's blog. Not only does it cover the 2000 blog that we looked at earlier, but there's a lot of other good stuff in there. And if you're curious, you can find out who these big fancy artists were that I was talking about earlier that Bryan used to work with in a previous life.
Yeah. Just a couple. Yeah, I'm pretty social media averse. I have 3 underscores in my formerly known as Twitter username, just because all the other formats were taken. If you find me on LinkedIn, don't bother. I don't update that. Don't look for me on Facebook. So if you want to reach out to me, get in touch. Just at me on the NetDev Slack. I'm there by name. I'll respond to you.
Awesome. Thanks again, Bryan.
All right. Thank you, Mark.